Hi, my fellow mathematician. Welcome to the study of differential equation. And differential equation is an equation involving the derivative of an independent variable with respect to one or more independent variables. Or you can talk of an equation involving the derivatives of an independent variable with respect to one or more independent variables. For example, you could be having an equation like this over dx squared plus 2x dy over dx minus 8x is equal to sine x. So this is a differential equation whereby now you have x being the independent variable and y. You could also have something like this: partial derivative of y with respect to partial derivative of t second derivative, which is equal to a partial derivative of u over partial derivative of x. In this case, y and u are independent variable. T and x are the independent variable. So you can see in this example here, the independent variable are 2 and the dependent variable are 2. Y and u are depending on t and x respectively. Basically, there are two types of differential equation. So we have types of differential equation. We have what is called ODE, ordinary differential equation. That is ODE. And we have what is called PDE. Depending on the college or university where you are schooling, ODE 1 is covered in that here, and also PDE 1 is covered in that here, or some universities they prefer to cover PDE in the fourth year. That is one of them. And then the second ODE and the second PDE is covered in a fourth year. Now, then we come to ODE. What is ordinary differential equation? O standing for ordinary, D differential, E equation. So ordinary differential equation is a differential equation that involves the derivative with respect to only one independent variable. So ODE involves the derivative with ordinary differential equation is a differential equation which involves the derivative with respect to only one independent variable. For example, when you have a second derivative of the function y with respect to second derivative of x minus xy is equal to 0. So this is an ordinary differential equation because the derivative involves only one independent variable. So in ordinary differential equation, the derivative involves only a single independent variable. What about PD? Partial differential equation. Now, in the partial differential equation, it is a differential equation that involves the derivative of one dependent variable with respect to two or more independent variable. So in the partial derivative, the independent variable are two or more. For example, if you have the heat equation like this, example of partial differential equation, we have the heat equation which is given by partial derivative of u with respect to x squared. This is equal to a constant a, partial derivative of u with respect to t. This is what is referred to as the EAT equation. It is a good example of partial differential equation because the independent variable is x squared and the t squared. Also, the wave equation, which is given by second derivative of u with respect to t squared plus a du with respect to t squared is equal to 0. This is the EAT equation along the xy coordinate. Also, the Laplace form of an equation, which is given by this, which is equal to 0, and which can be written as partial derivative of second partial derivative of u plus with respect to y plus partial derivative of u with respect to z. This is also the second. This is also the second. This is the partial differential equation because the independent variable, we have the dependent variable which is function u, and it is depending on x, y, and z. This is in 3 dimension. The next term we want to look at is what is referred to as the order of differential equation. So we look at what is referred to as order of differential equation. Now, the order of differential equation is the order of the highest derivative in the differential equation. So the order of differential equation is the order of the highest derivative in the differential equation. For instance, when you have an equation like this, when you have the third derivative of y with respect to dx minus 3x y is equal to exponential 3x. Now, this is an equation of order. So the order here is 3. Why? Because the highest derivative here is 3. So order of a differential equation is the order of the highest derivative in the differential equation. I can give us so the order here is order 3. When you have another example like this, dy over dx is equal to 2x plus 1 divided by 3x, or I can give 3y plus 2. The order here is 1 because the highest derivative in this equation is equal to 1. Then the next term we want to define here, it is the degree of ordinary differential equation. The degree of ordinary differential equation. So the degree of differential equation is the highest power of any derivative involved in the differential equation. The highest power. For example, if you have this equation here, second the derivative of function y with respect to x power 4 minus dy over dx plus 2y, which is equal to 5x. So in this equation, the degree of this equation, degree is defined as the highest power of any derivative involved in the differential equation. You can see here the highest power here is 4. So here we note that the degree of this equation, of this differential equation, is equal to this. So the degree here, the highest power is 4 and the highest derivative involved is 2. So the order is 2 and degree is 4. So in this video tutorial, we have learned the meaning of or degree of one-line differential equation, which is defined as the highest power involved in the derivative of the equation. Order, it is the highest derivative involved in the differential equation. As we have seen here, the order here is 3 because the highest derivative involved is that derivative. Here, the order is 1 because the highest derivative involved is 1. Then we have got two types of differential equation. We have what is called ordinary differential equation, whereby it is an equation which has, or it is a differential equation which involved derivative with respect to only a single independent variable, like this here now. X is independent variable, y is dependent variable. Then we have partial differential equation, which is a differential equation which involved derivative of a dependent variable with respect to two or more independent variable. Like this Laplace form of an equation, we have our dependent variable, which is u, and it is depending on x, y, and z. So this is a partial differential equation. So basically, differential equation, it is an equation which involves the derivative or derivatives of a dependent variable with respect to one independent variable or more independent variable. So thanks so much for watching this video tutorial with me, whereby we have looked briefly on the terms associated with differential equation. On the further study of differential equation, remember to subscribe to this channel, also to click on the notification bell so that you don't miss a single video which I upload for you every day concerning mathematics. Bye bye, see you in the next video. Remember also to share with other mathematicians so that we may learn together.